Hello, my name's Lieutenant Cayman Rowe. I'm from the Irish Air Corps Flying Training School here in Casement Airdrome. And I'm here as part of Science Week 2020 to discuss all things aviation. An understanding of science topics such as physics and earth sciences such as meteorology are absolutely essential for all aviators, especially military pilots. So with that in mind, today's topic is meteorology, specifically clouds. Most of us are familiar with clouds and how they're made. Moist air being lifted and cooled until the water vapour condenses out as water droplets. However, there's a lot more happening behind the scenes, and being a skilled pilot means being able to read clouds and understand the methods behind their formation. There's many different types of clouds, the main ones being stratiform, which is typically described as having considerable horizontal extent with little vertical extent. Cumuliform, which is seen as having quite a large vertical extent, and cirriform, which are wispy or hair-like in appearance and are only found at very high levels within the troposphere. Clouds can be classified further by describing their height above the ground. These are broken into low-level cloud, medium-level cloud, and high-level cloud, with the high-level cloud reaching the tropopause, or the furthest extent of the troposphere. Because of all these methods of classification, individual clouds can be described quite easily. For example, to name a few: stratus, nimbostratus, cumulus, cumulonimbus, and cirrus. So now that we know how to classify clouds, let's look at how they're formed, focusing specifically on convection cloud. Simply put, this is the process of warmer air rising as it's less dense than the surrounding atmosphere. Let's look at this graph, which has height on the y-axis and temperature on the x-axis. Firstly, we'll draw in the environmental lapse rate, which is the rate at which the ambient temperature changes with height. Next, we'll draw a line representing the dew point, which is the temperature at which the air cannot hold moisture any longer. Now let's imagine a parcel of air starts at ground level, where the temperature is 14 degrees Celsius. As it rises, it cools at a set rate of 3 degrees Celsius per 1,000 feet. This is known as the dry adiabatic lapse rate. As soon as it rises and cools enough to hit the dew point, moisture is released and our cloud base is formed. Our parcel of air will keep rising but will now cool at a different rate, known as the saturated adiabatic lapse rate, which is about 1.8 degrees Celsius per 1,000 feet. It will keep rising at this new rate until it comes into contact with the environmental lapse rate, at which point the parcel of air is now the same temperature as the surrounding air and any further ascent is stopped. Our cloud top has now been formed. Clouds have classically been described as signposts in the sky, as they're essential for indicating deteriorating weather conditions to the pilot, such as turbulence, poor visibility, precipitation, and icing. We've only scratched the surface of clouds in this video, but it goes without saying that clouds, as well as the further study of meteorology, is an essential part of any pilot's knowledge, and it's one of the many subjects students can expect to learn during their course of training here in the Flying Training School. Thanks for joining us on today's Science Week video. Ask us questions about what we've covered or what we do in the comments or as a DM, and we'll answer them as part of a question and answer session this Friday. Further information on what we do and recruitment can be found on our various social media channels. Join us tomorrow for another science topic viewed from an aviation perspective.